everyone. I'm John Lynn, the founder and chief editor at Healthcare IT Today. We're excited to bring you in another in our series of health IT interviews. And today's guest is Ian Eyberg, he's CEO of Nano VMs. Welcome, Ian.
Thanks, John, for having us. Good to be here.
Yeah, I'm excited to learn about an important space in the technology one. And as tech guy on Twitter, I love having these conversations because every day I lose a little bit of my tech guy skill. As a publisher, it's I love to at least dip my toe back in the tech side of things. But anyway, before we dive into the technology and things, tell us a little bit about yourself and Nano VMs.
For sure. So I'm the CEO, founder over at NanoVMs, and we work with unikernel infrastructure, which is kind of a new way of just deploying server-side Linux software that runs faster and safer than Linux itself. So.
Yeah, well, we want to dive into that safety thing. It's top of minds for healthcare CEOs, CIOs. I think it keeps probably the number one thing that keeps them up at night. But tell people, for those not familiar with kind of this container market, what's been the evolution of the use of containers in healthcare?
Yeah, so healthcare specifically, I would say probably the majority of the container users are more in kind of the startup space, your Ground Rounds and your Oscar Health and companies of that nature. I don't see a ton of work being done in actual more established like hospitals, for instance.
Mm-hmm.
You see some in like the data science realm when they're doing bioinformatics and things of that nature. But in general, I mean, a lot of it's just the various systems that they're already using, they've been using for a while, and that's not quite changing. But of course, that's where some of these other startups are coming in and offering their software. So.
Yeah, well, and I always am stunned by how many systems that a healthcare organization has, whether it's the latest ERP that they've rolled out or whether it's the latest whatever, where, they end up using it, right? Or they contract with someone like an Oscar Health or something for some service. But who do you see as really the market leaders in this space?
Those specifically using containers.
Well, not necessarily using containers, but the options that are available. I think Kubernetes is that the most popular one.
Well, yeah, I mean, there's most shops that are going to be using containers will be using something like Kubernetes. Mm-hmm. It's trying to kind of stand up your own container infrastructure is something that a lot of organizations fought a decade battle with and lost. So, even Kubernetes, the very first word that comes with that is complexity. So it's not really for the faint of heart in terms of, having to administer it and so forth. And so that's probably why you do see some of these older organizations leaning on your Oscar Healths and things of that nature, because they have, they come from that world. They excel in that sort of software delivery that maybe a traditional healthcare team might not have that core competency of, which is fine. I mean, their core competency is providing healthcare. So,
yeah. So why are people moving to this containerized world? And, is it about security? Is it about speed? Is it about flexibility? I mean, what are some of the advantages of kind of, obviously, in the healthcare world, we know about the monolith EHR, if you will, right? That gets rolled out, that's not containerized. What's the evolution that's happening here? Why are people implementing this container-based approach?
Yeah, there's a couple of things going on. One is that a lot of the modern software that's been written in the past, say, 5 years is being distributed as containers. So there's that. I mean, if you have software that's written in the past 2 years, I mean, you're probably deploying it in that infrastructure delivery mechanism. But the other kind of thing is that you have a very large swath of developers that don't wish to really deal with servers. And so containers have been this kind of thing that they reach to because they can just take ad hoc software from third parties and kind of roll it together and deploy it. And they don't really have to deal with, compiling it or making sure it works on one machine and it can transfer to another machine. So that's speed of delivery is one thing that these organizations look at.
Interesting. And will we see EHR vendors? I mean, certainly if a new EHR comes along, they probably build it this way. But
Yeah.
does it take like a full rewrite of the software for them to use something like this? Or
Well, I mean, if you're coming from something like an Epic, it's there might be some pretty dramatic changes going on. There's definitely a few very established vendors in some of these spaces. And so to kind of compete against them, I mean, you're going up against a pretty large incumbent.
Sure.
But I think some of those vendors are starting to catch up too. So it's not, it's definitely an evolution for them as well. Yeah. I mean, Epic started in the mid 70s or late 70s. So
79. Yep.
Yeah.
So yeah, I mean, I think you compare that even against Meditech, which is 50 years old, although they created Expanse within the last 10 years. So it'd be interesting to compare the infrastructure of those, but that's kind of a topic for another day. So, so tell us how, where does Nano VMs fit into this whole world? Like what's the difference between it and maybe some other implementations out there?
So I guess the easiest thing to distinguish is we don't do containers. We're kind of beyond that. Personally, our company views containers as kind of maybe a one step forward, two steps back type of technology, where there were some advancements made in terms of software delivery. It enabled developers to maybe speed a little bit faster in their development cycle because they didn't have to do all the standing up of various services. But then it introduced all sorts of different problems. Security became a nightmare. DevOps, it's one of the interesting things about containers and Kubernetes is if you look at a lot of the marketing that's involved with it, they talk about, oh, you don't have to do so much DevOps and less DevOps, and the very first thing that a company does when they adopt something like Kubernetes is go out and hire super expensive DevOps professionals. So yeah, it's a little bit misleading in my opinion.
It's just different DevOps, is that?
Yeah, I mean, the whole deal started with the fact that there's a large percentage of developers out there that they can write these applications, but they can't really manage the applications in production. There's monitoring that's involved, there's deploying that's involved, there's a whole set of skills that are involved in managing the software while it's running on a server. And there's a ton of developers that don't have that skill set. And so that's where Kubernetes has this promise of like dealing with it. So your application crashes, we'll just restart it. This is why we have these replicas. We can deal with the high load. We can deal with this. So that's where those frameworks kind of come in. But they aren't, as I mentioned, they introduce a lot of drawbacks as well. In particular, breaking a lot of security boundaries that existed before. So
yeah, so let's talk about that because we saw the news that the first Windows container malware happened. So what are the risks to do these containers pose for healthcare?
Yeah, well, I mean, before even jumping onto that article is actually not true. And it's funny because I think that came from Palo Alto, which is the exact same company that released an article a year ago talking about how Azure containers were completely broken by design.
Okay.
So the exact same company is kind of contradicting itself. They had an article like a year ago saying that, if you're using Azure containers, you should just basically stop because they're just broken by design and Microsoft has no inclination to fix them. You actually have to add on a tack on kind of service to deal with the inherent issue at play. And I'll kind of get at the real problem of containers. The real problem of containers is that they all share the same sort of kernel, the same sort of operating system kernel.
Right.
And that's great if it wasn't expanding beyond one server. But the whole idea of containers is that they're meant to expand beyond many servers. If you have a cluster but by definition, you're going to have many different servers with these applications writing on them.
For reliability.
Yeah. And that completely breaks like these core operating system security constructs that we have, compared to, say, a normal Linux virtual machine. You spin it up in Amazon or wherever. If I break into that machine, I might have access to that machine, but I don't immediately have access to all the other machines in your infrastructure. That's not the same thing with a Kubernetes. I break into one pod, your entire thing's it's completely host. So that's the really big, large issue with container infrastructure. And that's, why there's contrarians like us where we just, we see it as a fad that will eventually just kind of die out because it's just not, it's inherently broken. So
where will it head? Because there's a reason why Kubernetes is so popular and mentioned so much. I think it is the flexibility, the scalability, right? There's something about trying to solve the DevOps problem, right?
Right.
So where do you see it headed if it's going to die off?
Yeah, well, there's lots of different directions that it can go, but it's not the first time that stuff like this has kind of had a huge hype cycle and then kind of plateaued. Kubernetes is really just an extension of a lot of the platform as a service offerings that, had a big deal and then kind of pivoted and died out. So like Pivotal from Cloud Foundry, for instance, that was a really big deal. And, there's definitely, especially on the Northeast coast, there's still like a lot of Pivotal shops out there. It's basically dead. OpenStack, which is the clearest kind of correlation, even though it's kind of at the infrastructure layer, it's not dead. There's a lot of telecoms, for instance, that use OpenStack and many other organizations, but that same sort of hype kind of went up and then dropped sharply. And so now there's not so many organizations using that. At the end of the day, there's plenty of other stacks besides Kubernetes too. If you look at HashiCorp, for instance, HashiCorp is a multi-billion-dollar company that is the clearest example of a non-Kubernetes container-based infrastructure, and it's extremely popular amongst many organizations. So it's not. I don't see it as a binary choice. It's not if or. It's there's many different options, and then there's. As we mentioned, there's still plenty of software just sitting on Windows servers too. So it's you don't have to use Linux, although obviously people like me are very partial to that. So
yeah, well, I think that's the challenge for a healthcare organization. Many times they don't have a choice, right? Whatever software they choose is on Linux or is on Windows. It's on one or the other, and so they have to implement it. And I'm just kind of going back to this security risk element. I look at it and say, well, a healthcare organization's security risk assessment should take this into account.
Mm-hmm.
So, what can be really done to mitigate the risk of these types of implementations being compromised, or should they move away from them? Or what's your suggestion as far as making sure that the organization's at the least risk possible?
Yeah, I really feel for the healthcare organization because as again, I'll state, like, it's not necessarily their core competency to be writing the software and managing it. They need to use it just for, the various reasons, but really it's, responding to emergencies and dealing with the operations and all this other stuff. And containers present lots of different security challenges. You have the cryptojacking where some attacker will just inject an illicit crypto miner into some third-party dependency. It lands inside the infrastructure, and all of a sudden your resources are just being taxed by illicit crypto mining. It's a very popular attack now. You have all the ransomware where it's just nonstop nightmare. So, and honestly, a lot of that ransomware that doesn't even affect a lot of the Linux and container-based systems, although there are variants that do. Most of it's kind of residing on Windows, SMP shares and things of that nature. So that's its own challenge right there. Software in general just has a lot a lot of challenges. And it's, I think one thing is that the world just needs to wake up that it's not 1995 anymore. You know, it's 2021. Every single company out there consumes not just a little bit of software, but just massive amounts of software. And the problem's only escalating. And so I think, you know, the underlying infrastructure, it needs to be dealt with. We can't have these tack on solutions where it's like, oh yeah, well, we have the endpoint scanning and we have this, you know, software supply chain, you know, scanning. And most of the security solutions out there focus on scanning for hacked systems or scanning for systems that are going to be hacked, which to me is a very defeatist attitude. You know, in terms of dealing with the issue, you really have to figure out like why the attacker is getting onto the system in the first place, and then, you know, from there kind of walk back and figure out, okay, how do we deal with this issue? And that's where, you know, the technology unicorns like we work with kind of comes into play, where, you know, if an attacker is breaking into your server, they don't really care what software you have there. You know, they find a bug to a piece of software, they find an exploit, they break in. That's just the entryway to the server. It's like breaking a window in a house or kicking in the front door. It's just the entry point. Once they're inside your house, they want to steal your guns and your jewels and your money and your flat screen TV. I mean, that's why they're there breaking in. And it's the exact same mentality on the server side. They want to run their software. And so that could be something like dumping the database, which is every single data breach out there. You know, that could be running the crypto miner, but this always entails running on their software. And so, you know, from a unikernel point of view, what we say is like, hey, why don't we just run one piece of software per virtual machine, because we know it's already virtualized anyways. There's no need to have another general purpose operating system on top, where it's inherently built to run many different programs by many different users. And so that's kind of the philosophy that we espouse.
And is that what you see as the future of all of this, is really, you know, doing the one-to-one? And is the goal of that to really reduce the risk associated with, you know, from security perspective, or are there management benefits as well? Is that where you're headed?
Yeah. And I guess there's two thoughts here. I'll touch on the management side after, but, you know, if we look at security, you have to realize that the server side systems that we deploy to, and I'm really talking about Linux because we're talking about containers.
Yep.
You know, Linux is about 30 years old now. So it came out in 91. Linus, when he wrote it, was probably working on a 286. That was a real box, like a real machine. Yep. You know, and so the design characteristics of having multiple users, multiple processes, no virtualization whatsoever, you know, that those were just mandatory because that's what we had at the time. And this was the exact same design as Unix, which is now 50 years old, came out in 1969. It was built to work on machines like the PDP-7, PDP-11. Those machines took up an entire wall. They cost $500,000. There's reasons why these operating systems had this concept of running multiple programs by multiple users, because that's what we had to do back then. Right. The machines were just too expensive not to. Now, if we go back to Linus and Linux in 91, keep in mind that this was 10 years before VMware came out. So VMware was, you know, the first company that really commercialized virtualization. We had the concept in computer science for a while, but nobody had like really commercialized it. And I think it was also a function of market economics. We just didn't have machines that could really support it at the time either. Because, you know, we didn't have good SMB machines until like 2001. And SMB is really kind of a requirement for virtualization. But now, today, I can go to Google Cloud and spin up a 384 thread instance on Google, like in seconds, which is a beast of a machine. So yeah, there's a couple market functions that I think that allowed us to actually start to do this. And by the way, you know, keep in mind that even though VMware was out in 2000, it was still 5 years before that small company in Seattle called Amazon released EC2, which is what we call the public cloud. And the cloud is really just an API to virtualization. Really nothing more than that. So, it was VMware and Amazon are really kind of the two companies that set the stage for allowing us to even think about doing this. It wouldn't make sense without those two things.
And what are the management benefits then of, and where do you see it all kind of progressing? Yeah, because you're right. I think if I look back, my first computer was a 286. So it's fun that you mentioned that. It's like, we're almost spoiled with so many riches today,
right? Yeah.
As far as options that are available, that it's almost overwhelming to know what's the right direction.
Yeah. So the management question is really interesting. And to give you some context, I'm here in the Bay Area. So let's say you're an engineer that works over at Uber or Airbnb, or name any of your favorite unicorn tech companies. Mm-hmm. Those companies are so large and they employ so many software engineers that they don't have like one database. They don't have one web server. They have thousands of web servers, thousands of databases. I mean, there's graphics you can go look online where they show you this cobweb constellation of little dots, and there's just like thousands of them. And they're like, yeah, these are all the different applications that we run in our one company. Yeah. And what you have to realize is they call them applications, but they still reside on individual operating systems. And so, a company like Lyft signed a $300 million deal with Amazon for, I think it was over a 5-year period. So $300 million they've committed to spend. And you just think about the mess of operating systems that they have to control. Because again, it's not just like one operating system, it's thousands and thousands and thousands of them. And that's a real cost. Here in the Bay Area, a good DevOps engineer, SRE, whatever you want to call them, some of them can't code at all. They just manage systems. They can make $200K a year. And so that starts, eating up a lot of valuable time. And I think the management issue is going to get worse and worse and worse because we keep on adopting more and more software. Google is famous for, they wrote a paper, then they wrote another paper, and finally this paper turned into a book. And it basically said that the data center is a warehouse computer, which is a pretty apt metaphor of like where we're going, I think. And the problem though is if the data center is a warehouse sized computer, then the cloud is the operating system, yet we're still managing thousands of different operating system installs for our software. And so what the unikernel does, if you're deploying to the cloud, is that we deploy each application as its own VM, and there effectively is no kind of user land operating system. It's when you spin it up on AWS, the application starts and that's the only thing that's running. There's no Linux inside. There's nothing to manage. It's either working or it's not. It's running or it's not. And so a lot of that management and configuration and deploying issues and monitoring issues, and a lot of that stuff just gets thrown out the window because it's just not present anymore. And I think that's the direction that we're going. And things like Kubernetes and containers have kind of done that one step forward with it, but we really needed to rethink it completely in order to kind of push it down the road. Because like if you deploy to the cloud today, Google or Amazon, you're not just deploying your server, your Linux server on top of there. You're actually sitting on another Linux server, at least one, maybe more. So there's like 2 layers there, and we just don't need that second layer of abstraction anymore. Not if we know it's virtualized.
Interesting. Well, I think a lot of healthcare CIOs and health IT leaders will really relate with what you just described as far as the number of applications we have to host, the complexity we have to host, and the need to simplify that, right? So that's a really great message, and I want to thank you so much for taking the time to share these insights and perspectives. And thanks everyone for watching. If you want to find more great healthcare IT content like this, be sure to check it out at healthcareittoday.com. Thanks, Ian.
For sure. Thanks.